Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Design of an Efficient Fuzzy-Based Cluster Routing Protocol in Wireless Sensor Networks. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the applications that we have designed for the control systems in the network. So basically, this is basically in the distributed environments where we are designing controllers. Those are handling the control systems in the network. So this domain is related to the communication. So let's start with the video. Before moving to the video, let's talk about that what we will cover into it. In this video, we will initially talk about the application areas where this can be implemented. Then we will talk about what code we have developed and how to execute it. What are the software requirements for that? Next to that, we will talk about what are the current systems and what exactly we have done in the proposed system. Finally, the result overview will be given. So let's talk about the application area. As it is related to the communication, so this is not restricted to only one domain. Any of the smart systems, smart agricultures, buildings, industrial, biomedical application, intelligent transportation, wherever the data is to be transmitted from one place to another by taking some certain decisions, there this particular application can be helpful. But the difference of it with respect to the other domains is like this is for the network controllers, not only the routing protocols or handling the data. So that is the uniqueness of this particular topic. So let's move to the code. So for running the code, we will provide you the folder name code under which all the files has been placed. The whole code is being implemented in the MATLAB, so you must have the MATLAB software with you. So in the MATLAB software, the version that we are using is R2019A, so you can use 2018, 19, whatever is feasible for you, but make sure it should be a full version, not the trial one. So in order to run the code, you just need to go to the folder, just copy the path of the folder and then go to the MATLAB and then paste it here and press enter. You can see all the files can be seen here. Out of all these files, the code file that you need to run is one is this opticode, another one is opti hybrid code. So this is the version that we have implemented with the technique, and then we have improved that particular technique with the method. So along with that, we have designed the n-phase algorithm which we have given into this method, so you can see the whole scenario in order to understand that when we are working with the fuzzy or the neuro fuzzy. So next to that, we have designed the system with the delay and the without delay, and overall comparison can be seen under the compress. So we do have the main file this and this. In order to run this, you just need to click over the file and click on the run button. When you will click over the run button, it will start executing. You can see it seems busy. The code is using the Simulink models also, so it will take so much time to execute the whole procedure. So I'm just pausing it for now and going to discuss that what exactly we have done and what was the issue. So many of the network controllers are present in the market, and they were facing certain issues, including handling the data and controlling the output factors. So I'm just closing it, just wait a minute. Okay, so for that we have designed certain models. One of the model which was earlier designed in R2015B, but we can open it in current system also. So initially the people were working in the domain for the network controllers with the PID controllers, PI based controllers, or the combination of PI or D, any of the set they used to make. Then recently the fuzzy based systems has been introduced in the market. Those were working for controlling the models and achieving the output in maintaining the overshoot and getting the effective outcomes. So here you can see we are using the LTI model, out of which the name given is RTD with us. So we are developing three of the model. One is for the conventional PID where no control unit has been introduced to it. In the second scenario we are working with the fuzzy based PID where the parameters of KP, KI and KD are decided by the fuzzy. And finally the neurofuzzy, which is the proposed section of ours, in which the neurofuzzy, which is the combination of neural and fuzzy, has been introduced along with the PID to take the decision. So now the problem that we have identified is like there should be an intelligent system that can take the decision to decide the parameters of PID as per the inputs. But in the fuzzy, because it is a rule based system, so the user defined rules can be there. So if we will talk about the fuzzy logics, so you can see this is a type of logic that is used to affect computer behave like a human brain. So normal concept, if we are going to see the images for the fuzzy logics, it is basically having some few inputs. Let's say this one, there are few inputs, then on that behalf the set of rules has been given. This can be more explainable here. You can see these are the two inputs. Here the rules has been defined, and on that rules based an output is to be decided. But the problem that we identified with the fuzzy is that when there is a fuzzy that is a fixed one, if the inputs will be as per the fuzzy rules or the inputs, then it is easy to take the decision. But when the decision is to be taken with the new inputs which are not as per the rules, so in that scenario the fuzzy give a random solution which is not effective for any of the system. Whereas in neurofuzzy, along with the fuzzy system, there is the power of neural networks which capable to take the decisions by seeing the patterns of the rules given by the user, and it assists the fuzzy to take the decision even in that scenarios where the rules are not already defined as per the inputs. So that's why we have introduced the concept of ANFIS. Secondly, other than that, we have implemented the scenario where the parameters of the system are being defined by the optimization algorithm, where in the earlier stages the people were doing by working with the manual entry of the parameters. As you can see, if I'm opening it, this is the proposed model, and here if we will talk about the PID controllers, these were the PID values, and when it is for the fuzzy PID, so you can see this is the fuzzy interface system. So these are the parameters on which basically the value is to be decided, that what exactly will be the output, right? So that is decided by the manual procedure in the earlier stages. In the proposed method, we are giving a technique, one of the technique where we are implementing GW optimization algorithm, and then we are improving the GW algorithm by proposing the hybrid method. So hybrid method that we are proposing is basically the GW and Firefly optimization algorithm. So GWO is basically a method, optimization method. So you can see Gray Wolf optimization, so you can read about it. So it is basically Gray Wolf optimization, and second is Firefly optimization algorithm, so which is termed as FA algorithm. So we have created the hybridization of GW and FA in order to support the GWer to get the better outcome. So the parameters, those I have already shown you on the Simulink, are captured from this optimization algorithm, where the fitness is being evaluated. Here is the fitness function by putting those values to the models that I have just shown, and from the simulation whatever the results are out, we are checking that how much overshoot is there, how much setting time is there, how much rise time is there. So in order to reduce these things and maintaining the output of the system, we are selecting the best factors, and after achieving the best factors we are sending them for the simulation and getting the final results. So if I'm going to run this, you can see it will take so much time. So we have just run it earlier and saved the results by using the save commands. So they are showing us the result in terms of different controllers with the PID, fuzzy PID and NFIS PID with the normal GWO. Then in the second scenario we are applying it with the hybrid of GW and FA for the normal PID, fuzzy PID and neuro fuzzy based PID. So let's run this. You can run it individually and take devote time to get the results. Even you can change the configuration if you want to. And this is for the proposed scenario, and this is for the neurofuzzy evaluation if you want to see. So all these three scenarios can be individually evaluated. Final, the results has been saved in the two terms of traditional GW and hybrid GWFO based model. So when I'm running it, you can see it will show me the results in terms of different factors even in the graphical. So let's have a look to the tabular form. So here you can see for the online settling value without delay, because we have considered two of the factor, one is delay, another one is without delay. So here you can see when it was about the traditional model, so we were getting the results in these terms, where you can see the overshoot get reduced, the rising time is better and the settling time is less, and even for with the delay it is better with the NFIS PID. And in the final hybrid model you can see it is further reduced to a certain value, which is effective in comparison to the previous phase of the GW based method. So further modifications are still possible into it. In this, neurofuzzy has been implemented, where we have initially defined the variables for the factors that we need to decide, which is basically two of the factor, one is E and another one is change in E. E is the error and this is change in error, and on that behalf fuzzy has been defined. We have also trained the neurofuzzy as per this data, and then got the trained neurofuzzy, which is further used in order to take the decision that how much value should be there with the features. So the transfer function has been defined with delay and without delay, evaluated the PID, got the outcome. Finally on that we have decided the value of Kp, Ki and Kd, and finally decided the factors. So this was for the normal PID. In the fuzzy scenario, the whole fuzzy system has been implemented, where only whatever the rules have been given, accordingly it will decide the outcome. So here you can see the PID tuning with the fuzzy has been done, and with and without delay, and finally the results for the both the models has been used and simulated, and on that behalf the results is being shown here. So this is how you can execute the whole code. I'm going if I'm gonna run it, it will obviously take so much time to get the results, so you can run it. I recommend you to use the MATLAB 2015. This is the system that we have designed. You can see it is plotted through the code. So I recommend you to use the MATLAB 2015 first. If you will face any issue, then you can move to the 2019, because there is a size variation among the setup. So the code was also runnable in the 2005 version. So all these results and graphs can be seen over there. So further modifications are still possible, because neurofuzzy's training and other factors can be dynamically adjustable, so that to give more better results in terms of the certain factors that we have decided. So the factors we have decided for that was overshoot, rise time and settling time, with and without delay. Two of the scenarios were there. So I hope you people like this video, and for further details you can contact us directly and can get the details. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPax, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends, synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPax. We look forward to collaborating with you on your research journey.